Hi everyone, in this video we're going to go through 3A, which is on simplifying surds. I do apologise for my nasally and disgusting voice, but hopefully you can bear listening to me as I explain this content. So to start off with simplifying surds, we do need to know what a surd is, and depending on which class you're in last semester, you might have done different things with them. If you're in my class, we hadn't learned to simplify surds yet. So just so we're all aware, a surd is an irrational number that uses a root sign. So for example, if I said to you the square root of 4, hopefully you could tell me that a number squared that gives us 4 is 2, so the square root of 4 is actually equal to 2. However, if I asked you for the square root of 5, now that's not a perfect square. We don't have a number that simplifies into that surd, and we could put it in our calculator, and we can see that it gives us this decimal here, 2.3606. etc., etc. That's going to keep going on there. My calculator here just has cut to give us numbers to 10 digits, I think it's set on. But we can also see that with those decimals, there's no pattern there as well. So surds are considered to be irrational numbers, and just in this little infographic that I have on the screen there, we can see on the left we've got these rational numbers. And these are numbers which can be written as a fraction. It says in the form a over b, where a and b are integers. And there's a few different things. So we've got terminating decimals, i.e. decimals that end. We've got recurring decimals, so ones that go on and on and on. So over here, for example, we could have a third written in here because that would be 0.333 recurring. And have a subset of rational numbers. We've got our integers, which is our whole numbers. We can have negative integers, or we can have our natural numbers, and that can be 0, and then all our positive integers as well. Over here though, we've got our irrational numbers, and they can't be written in that fractional form as a over b, where a and b are integers. So we've got our surds and other irrational numbers that we've worked with, such as pi. And if you go on to then work in methods, and especially specialist maths, you'll work with complex numbers and learn more about other irrational numbers there. So for the purpose of this, we need to know that a surd is an irrational number, it uses a root sign, and it cannot be simplified to a whole number, i.e. that root 5. Now, the first question here, and there's some in your textbook, they just get you to express the following numbers as decimals, decide if they are rational or irrational numbers, and then find them on a number line so that we can think of their perspective in relation to other numbers. So, our first numbers that we've got to work with here, sorry, my pens, come on, is we've got negative root 2, 150%, and we've got 6 over 7. So first of all, it just wants us to write all of these as decimals so we can compare them. If we put in, sorry, it did say negative root 2, that gives us negative 1.4142 blah blah blah. So we'll just write down negative 1.4142. 150%, we could write that as a decimal as being 1.5, and 6 over 7, if we check that in our calculator, we get 0.857, etc. It continues on and on. Now, we need to decide, that one does terminate though and ends. So we need to decide whether these numbers are irrational or rational. So our surd is an irrational number, and the next two are rational numbers. And the final part is we need to locate these on a number line. So I'm going to put 0 here, and I will just label in for us -1 and +1. So we've got a bit of a scale to work with. Now, negative root 2 was negative 1.41, etc. So let's put this out over here, and we'll call this negative root 2. 150% is positive 1.5, so that'll be out there, slightly more positive than the negative root 2. Sorry, I'm just going to change that to be 150%. And 6 over 7 will fit somewhere in here. So those are our three numbers labelled. Our next step then for this exercise is us to be able to simplify our surds. Now, again, if you were in a different class in the first term, you might have already done this. If you're in my class, we didn't learn how to do this yet. The first thing that we need to know are these two little points here, which are like a law that we can work with. If we've got a surd and we can think of it as being a multiple of two numbers, so we've got the square root of xy, we can actually rewrite that as being two surds that are then multiplied together. So root xy can be split up into being then root x times root y as two separate things. And likewise with this fraction here, if we've got the square root of an entire fraction, we can actually split it up to be the surd of one number on the numerator and the surd of the second number on the denominator. Now, using those rules, when we look at surds, we need to look at the factors of each number that sits under the surd sign. And we need to then try and remove out perfect squares, because we know that perfect squares are not a surd, they're a whole number, and so they're numbers that we could simplify out to the front. So I've got here 4, 9, 16, 25, etc. So like if you want, you could write here that we know 4 is 2 squared, 3 squared, 4 squared, etc. So I have a few examples for us to look at together. So the first one here, we've got a root 18. Now remember, we want to think first of all, what are our factors of 18? And if we think about them, maybe you tell me the factors of 18 are, sorry, my pen's being annoying. You tell me factors of 18 are 1 and 18, 2 and 9, 3 and 6. And if we look at those pairs there, 2 and 9 here includes a perfect square. So what we can write here is that root 18 is also equal to the square root of 2 times 9. Actually, I'm going to rewrite that as 9 times 2, sorry. You'll understand in a second. I can also think of this then as being two separate surds. So this is like saying root 9, root 2, and technically there's a little multiplication sign in there. Now root 9 is a perfect square. We know that root 9 is equal to 3. So what I can do here, root 9, we can actually simplify that to be 3, and then we're left with 3 root 2. If we look at B here, this one's a little more complex. We've actually already got the 2 as a whole number at the start, and we just want to think about then 162. 162, it is a big number. It's a number we might not be used to. So sometimes with big numbers, I just think if I divided it by 2, what would I get? And 162 divided by 2 actually gives us 81. And 81 is a perfect square. So what we'll write up here is we can rewrite this as being 81 times 2. If you like, you could rewrite it like this straight away. And this then, root 81 actually simplifies to be 9. So out the front, we're now going to write here 2 times 9 because those whole numbers will actually multiply with each other. And so our coefficient at the front here is going to be 18, and then that will be root 2 afterwards. Got a few more examples here. If we look at C, this time we've got root 54 as the numerator of our fraction and just a whole number 12 as the denominator. So if I simplify this numerator first, 54, there's lots of different factors that you might think of. I'm going to go with 9 times 6 and just rewrite it to start with as root 9 root 6 over 12. I know that root 9 simplifies to be 3. I can't simplify root 6 any further, so I've got 3 over root 6 over 12. And these guys have a common factor. They're both divisible by 3. So my final answer here will be root 6 over 4, because I can take out that common fraction. Finally, with D, remember that second rule that if I've got a square root out the front of both the whole fraction, I can rewrite it as root 125 over root 16, so I can put the surd symbol to both numbers and I can focus on them separately. Now root 125 I could rewrite as root 25 times root 5, still over root 16. And then 25 over 5, root 25 root 5. The root 25 just simplifies to be the whole number 5. I'm still left with root 5, and root 16 simplifies to be 4. So that there would be my final answer. With simplifying surds, you'll notice numbers like root 18 comes up a lot. You'll also notice ones like root 8, root 12. So there'll be ones that you start getting used to and that you start to remember off the top of your head anyway. The final question here, it says express these surds as a square root of a positive integer. This wants us to do the reverse and create them as surds now, where their answer would be totally under a surd symbol. So first of all, 4, to put it back into a surd, we want to think what's 4 squared, which is 16. So this would be 16 root 2. And we know with that rule, that means we can actually multiply those two surds together. So this one here would simplify to be root 32. And over here, 3 squared is 9, so we could write root 9, root 11, and you could write the next step, or you could just multiply them together in one go if you like, and that will give you root 99. I hope that was helpful for you to learn what to do for 3A. We're going to need to simplify surds all of the time going forward. So we need to be able to break them down and look for those perfect squares so that we can always write our surds in the simplest form possible. Thank you.